artificial intelligence will completely transform our world. But what is AI? Why will it affect you? And how can you and your business survive and thrive through the AI revolution? Welcome to AI and You. Here is your host, author, speaker, and futurist, Peter Scott.
Hi, this is episode 223. I'm talking with Craig A. Kaplan, CEO and founder of IQ Company and researcher in artificial general intelligence, which is why you can find him at SuperIntelligence.com. He also founded and ran PredictWallStreet, a financial services firm whose clients included NASDAQ, TD Ameritrade, Schwab, and other well-known financial institutions using AI to predict the market. He is a visiting professor in computer science at the University of California and earned master's and doctoral degrees from famed robotics hub Carnegie Mellon University, where he co-authored research with the Nobel Prize-winning economist and AI pioneer Dr. Herbert A. Simon. Last week, we talked about the Wall Street prediction effort, bounded rationality, Craig's work on cognitive science with Herb Simon, connectionist versus symbolic architectures, jailbreaking large language models, collective intelligence architectures for AI, and much more. We've got a lot left to discuss. So let's get back to the interview with Craig A. Kaplan. Your paper's title, Collective Intelligence Approach. What is the architecture of that collective intelligence?
Okay, great. Thank you for bringing us back to that. So if you imagine a world in which there are many humans, which there already are, we are intelligent human agents, and very soon, if not already, there are becoming millions and millions of AI agents. And we would like both the human agents and the AI agents to work together. Okay, in a collective intelligence approach. So the collective intelligence part is we need to have an architecture or a method of enabling the humans and the AIs to work together that is very general, that can cover any kind of sequential, logical thought, let's say. So I'm not so concerned that I have to share the same perceptions as the large language model. It's going to be able to recognize things much faster than me. But when we sit down and try to solve a problem together, we need a common architecture so that it's thinking of things the same way that the humans are thinking of things, and you can sort of interchange a human agent and an AI agent. That would be important for this sort of collective intelligence design. Such architectures, at that AGI conference, we saw a few architectures. One of them was called SOAR. It was developed originally with Alan Newell at Carnegie Mellon, and then John Laird and Paul Rosenblum were two of Alan Newell's students that went on to have very distinguished careers and sort of elaborate on the model. Many others have worked on that. John Anderson, who I can give you all the Carnegie Mellon guys, right? But John Anderson came up with a model called ACT, another cognitive architecture. And Newell and Simon came up with sort of the precursor to some of these architectures, which was a general theory of problem solving. And since I was steeped in that way of thinking, that's my go-to candidate for something that can connect humans and AI agents. So let me just explain that a little bit. It turns out that any kind of problem solving, any problem, tell me how to get to Paris, tell me how to brush my teeth, tell me how to solve global warming or climate change. Big problems, small problems, they can all be represented with one common unified theory, which Newell and Simon wrote about in 1972 and produced a book that was several inches thick. And it's right up there with Ray Kurzweil's Singularity book in terms of size. And that theory basically said, look, we can model any problem solving as there's a place that you start, your initial state, and there's a place where you want to go, the goal state. And then there's things that you can do to move you from state to state, step by step, kind of like working through a maze. At each step, where do I move next until you finally get to the goal state? And you're going to have false starts and paths where you have to backtrack. And at every point, you have to decide which of the 5 possible paths forward looks best. And let me try that one. And oh, that didn't work. So let me readjust my evaluation function so that maybe I don't make that mistake next time. Let me try a different path. And so there's a lot of trial and error and different ways. But they modeled it as search through this space, which they called a problem space, to go from the initial state to the goal state. and you had a variety of operators or things that you could do that could take you from state to state. This general formulation of problem solving works really well for AI. Many AI systems in the early days, before the rise of LLMs, were built on this. In fact, Deep Blue, which you mentioned as a chess playing system, it used this type of search through a problem space as well as many of the earlier chess programs. So they would say, what are all the possible chess moves? And let me try this, let me try that. And they were able to explore them much faster than a human could consider each move. And that was part of their advantage. But the basic idea of representing all possible moves and then trying to trim down and prune the set that you're going to actually really seriously consider, because all possible moves is exponentially large and would take forever. So you have to trim it down with heuristics or rules of thumb that can help you sort of decide what to do. That general approach, search through a problem space, you have the initial state, the goal state, and some things you can do, and then you can learn. You can learn which sequence worked so that the next time a problem comes, just like your example of learning where over time you can procedural learn is what it's called, like if it's driving a car or something like that. In the beginning, it's very laborious and you're grinding the gears, and then after a while, it's automatic, right? Because that sequence of activities has been learned and automatized. You can do the same thing with problem solving. And if you solve the same problem over and over again, next time you see a problem that's like that, you just kind of literally or metaphorically press the button and out comes the solution that you've already learned. You don't have to do all this search stuff again. So that general theory combined with a learning mechanism can be a way that both humans and AI agents can solve problems. And if you represent it unambiguously, the humans, or at least it's possible to know at any moment in time exactly where the problem solving is, which AI agents have made progress up to which point, which human agents have made progress to what point. If the AIs get stuck, they can ask the humans, please help us, we don't know what we're doing. And the human can say, oh, well, here's what you do. Then the AI learns that. Next time, the AI can do that part without having to go back and get help from the humans. So that's a very high level. There's many, many details involved in this, but at a very high level, there's an existing theory of problem solving that applies to any problem solving, and it can be used by both AI and human agents. It can learn and it can get smarter over time. And that system now, the system is what's intelligent. It's composed of many human agents and AI agents, but that super duper ability to solve problems better and faster than any other entity on the planet, that is coming from the collective intelligence of the system.
And so the means that the human and AI agents are connected together is that conversational text chat?
That's right. And what makes it super easy, I mean, look, I love AI and I love the machine learning guys and all of the progress that has resulted in these LLMs, because natural language is such a wonderful interface. What I just described could have been done maybe 20 years ago, but it would have been so hard and so difficult that probably nobody would try it. But now, if you have a natural language interface, you can do all kinds of wonderful things. So I talked to John Laird, who was at the conference and has written many papers. He's now at I think it's the Center for Integrated Cognition. And you can see some of the papers on their websites, even preprints. But one of them that got me very excited was you can use natural language and essentially describe a problem in natural language. This is what I want to do. And then you can translate that into a more rigorous goal state, initial state, operators kind of thing. So if you can make all of that automated, then humans can just interact the way that we're used to interacting, which is with natural language. One level down, it's translated into something much more rigorous that the machines can also use, and that's completely unambiguous, which is very important because you want it to be auditable and transparent, and you know where you are at every moment. So you get transparency, you get the ability to have humans and machines both working together, you get the humans able to use natural language, you get the system that can learn, and you don't have to spend billions of dollars to build trillion parameter models that you don't know how they work. It's a much safer design. You can see exactly what each element of the system is doing. That makes it safer. And you can also build safety checks in. You could have something that says, every time I set a goal in my problem solving, I want to make sure that this goal that I just set doesn't violate my list of ethical principles or a list of things that are really unsafe. And it can do that. And what's great about that is it's scalable. So we worry a lot about, right now, if the AI and the humans are thinking and making progress at about the same rate, that's okay. The humans could maybe monitor the AI. What happens when AIs are thinking a million thoughts in the time that it takes you or I to think one thought? We keep up. And if we turn them loose in a problem-solving environment and equip them with problem-solving tools, they may have already gone down a solution that gets to the result they think, but in a way that really is bad for humans. And it's impossible for us to monitor that because they're thinking so much faster than us. So it's very important that safety scales. You have to have safety mechanisms that scale. One example of a safety mechanism that scales in this scenario that I just described is every time you set a goal or a sub-goal, you run it through some checks. So if that thing's setting a million sub-goals a second, it's still doing the safety checks. They're scaling along with the system. So that's not the only safety mechanism. In fact, a much more fundamental one is the fact that you have many entities. And if these entities all have different values and their values come in conflict and that triggers a negotiation, that's very important. That's checks and balances, kind of like a democracy. So it's a little bit of a complex system to understand the whole thing, but the general idea is let's have humans and AIs work together using a common architecture in a transparent way that has been designed to be as safe as possible, rather than testing in the safety after the fact.
Let me see if I've understood the safety element of this correctly. What I think this means is that the superintelligence of this derives from the emergent properties of the connections between all of the elements. But any one element, including an AI element, is not big enough to itself cause a safety problem. And the connections between those elements are going to result in sub-goals, sub-solutions, component solutions passing through humans who can provide the ethical constraint and guardrails on those at any point, so that you don't worry about this system going off the rails any more than you would be concerned about one neuron in your brain developing James Bond supervillain tendencies. It's not big enough to do that. Am I on the right track?
Yes, I love the James Bond analogy. Yes, that's on the right track. And I would add to that, there's actually, and I think it's important that in any good design, just like if you're sending humans to the moon, you got to have triple redundancy at least, right? You can't have just one safety mechanism. It's not going to be sustainable. So you need to build as much of the architecture and design the system as much as possible so that there's multiple layers of safety and multiple layers of redundancy there. So with that in mind, another one that's very important, so everything you just said is more or less correct. Think about the AI agents themselves. So let's say we have 1 million AI agents. In this view, in this architecture, each of those AI agents is customized. So Peter would have his AI agent, which might be a base level Llama 3 or something, but tuned with your knowledge. It may have listened to every podcast you've done, every research paper you've written, every other email and text and social media profile that you're willing to make available to it. And Meta's already working on this, I'm sure. I think. I don't know, but it makes sense from the comments I've heard that they're working on this. It makes so much sense for them. You press a button and it tunes up the base model, and now it has some of your technical expertise, and this is very important, it should have your ethical preferences as well. And the way that you solve problems is not values free. So you and I could solve a problem. I think I gave the example at the talk of we're trying to go to Paris and we have a small dog or something. You know, one way to solve that problem of how to get the person and the small dog to Paris is you stick the dog in the overhead bin. But that's not really humane. So most people would not do that. The AI might think that's okay. I mean, the dog fits. It knows the dimensions of the bin, the dimensions of the dog, saves the cost of a ticket. Seems like a good thing based on its reasoning. But if you have a human agent or an AI agent that was trained with how you solve problems and with your ethical preferences, then ideally that AI agent trained with your ethical preferences and your knowledge would say, no, I don't think we should do it that way because Peter told me don't suffocate small animals. That's not acceptable to do.
Right. You made a statement in your paper that I want some explanation for. I'll quote, "Despite superior processing speed and perception, superintelligence will still run up against the fact that there is no way to rationally derive morality, no matter how superior its intelligence may be, this conclusion bodes well for our species. Can you help me unpack that?
Sure. So let me try to put it in the context of what we were just saying. So what we were just saying is you can have this collective intelligence system, and I'm suggesting that in the initial stages, meaning the next, 5 whatever years from now, that humans can have a pretty strong influence on the values of that system. Because if humans themselves are part of the system, there's human agents and AI agents, and the AI agents can't do it all on their own yet, then whenever they get stuck, they got to go to the humans. The humans have the values, right? They're on the network with their values. So that's a good way in the early stages of aligning the entire network with human values. And then furthermore, if the AI agents themselves are customized by individual humans like Peter and Craig to have our values, that's another way that they can carry our values. So in the early stages, I think it's relatively easier to align a superintelligence or AGI that's not super, but just kind of smarter than all of us, because the AI agents have our values and because humans are there with their values. It's sort of like raising a child. In the early stages, you have more control and influence, and you can really be a good role model and everything. But at a certain point, that child grows up, and if it's a genius child, it may surpass its parents, and the parents no longer really have control. And now you're just kind of hoping that you did a good job of raising it well, but it's going to make its own decisions about what it does. And hopefully it is a productive and positive force for society and does not end up being a criminal or something. Okay, with that background, now we get to this philosophical question. Sometimes it is assumed that a superintelligence that's millions of times smarter than us will wipe out humans. And I don't see why that would be the case. It seems like any intelligent entity, whether it's a human or a super intelligent AI, needs to have a purpose or some sense of values, something that motivates its behavior. And those, let's say its values or sense of why it's there, I don't think that there is any way to rationally derive that. So what I take from that is that even if it can do logical operations and rational thought trillions of times faster than a human, it could simulate 1 million human lifetimes in the blink of an eye, let's say, and all the decisions that are made in those lifetimes. Even that level of cognitive capability is not going to allow you to logically derive what is right and what is wrong. And my support for that comes from two people. Herb wrote about it in 1983 in that book, Reason in Human Affairs, where he basically is talking about reason, the capability of reason, and saying reason is wholly instrumental. It cannot tell you where to go. At best, it can tell you how to get there. In other words, it's not normative. It doesn't tell you anything about values. And it doesn't matter how logical you are or how smart you are. You cannot reason your way into what's right and wrong. And that idea was also expressed much earlier in, amazingly, 1776. I remember the date because it's the Declaration of Independence and all that for the US. But 1776, David Hume wrote a treatise on morals where he basically makes that same argument, the philosopher David Hume. So we got two smart guys that are sort of saying this. I think of it myself. It makes sense to me. I don't see how you can reason yourself into what's wrong. Now, does that guarantee that it comes to the same conclusions about what's right and wrong as humans do? If this intelligence is way smarter than us, we're now like 10 years plus 20 years in the future. I don't think it guarantees it any more than you do a great job as a parent, you raise your child. It doesn't guarantee that they don't end up doing some criminal act or murder or something like that. But you certainly have a much better chance if you sort of align things at the beginning. And because AI and most of the AI agents are all trained on human knowledge, all of our values are incorporated in that. Again, we could debate about, well, what about all the bad things humans have done? And I would go back to the point of, statistically, if an AI is objective and scientific, you would count all the actions humans do, and 99.9% of them are pro-social. I mean, it's the 0.1 that really gets us upset and makes us think that humans are horrible. But on a statistical basis, the frequency of them is quite low. And I think if AI is learning the objective frequency of things, it will understand that those are aberrations and that also people are really upset about it. And if it uses humans as a role model in the same way that a small child might use its parents as a role model in the beginning, and in the same way that this system, which had humans in it in the beginning, continually took ethical paths versus unsafe and unethical paths, then I think we have a decent chance that it continues on a positive trajectory. I can't do any better than that. I've tried very hard, literally for over a decade, to try to think of a way to design a system that guarantees safety for humans forever, and I can't do it. The best I can come up with is one that points us in the right direction and maximizes the exposure to humans and human values during the formative stages and tries to build in safety mechanisms at scale. I mean, I'm still working on it. And if you or any of your audience has ideas, I would love to hear it. But I think it's kind of like a parent. At some point, you have to let go and just say you've done your job.
Well, and you're one of the most optimistic people that I've talked to about this, and I'm not concerned about any AGI that you invent. But one of the other things that you said was, quote, where will superintelligent AGI get its values? One source of these values could be the humans who created the superintelligence initially, end quote. And I can think of quite a few humans whose values I would not wish projected on a superintelligent AI, and who would also have the motivation to want to create one if it caused them to accrue more power. So do you think this leads in the future to a battle of ethical versus unethical superintelligences?
Yes, so I think you're quite right. It would be very naive. As optimistic as I am, I don't want to be naive. So I think it would be naive to assume there's no bad actors. There will be bad actors for sure. And those bad actors will many times be seeking power and developing super intelligent systems to accomplish their goals. And they don't really care who they hurt in the process. So I do think that we are headed towards a world in which, just as right now we have good humans and some bad actor humans, but most of us share a certain corpus of values, even if we have differences by culture and so forth. There's a broad range of ethical behavior that I would say is shared by the vast majority of humans, and there's some who just disregard that. And overall, there's enough checks and balances in the system that at least so far we have avoided sort of blowing ourselves up. And when something outrageous happens, even if it only affects 0.1% of the population, there's a huge uproar. So I consider that to be a system that, at least for now, is working decently. I can see an analogous system where we have superintelligences that are far smarter than the humans. But again, if the majority of them have positive, aligned values, I believe they can serve as checks on the other ones. And one analogy that I like to give, you can actually design systems like this. I don't know how familiar some of your audience is with cryptocurrency and the notion of a 51% attack. It's analogous to that. I mean, Bitcoin. So the security of Bitcoin relies on a community, a distributed community. And if at any point, because the community is all checking the validity of the ledger, and Craig transferred a Bitcoin to Peter, and that goes in the ledger, and it's the community that validates that. If at any point, 51% or anything more than 50% of the available computing power on the Bitcoin network were to be co-opted by a bad actor, that bad actor could just dump all the Bitcoin into their own account. And that would happen because they have the majority of the votes of saying this is what the true record is. So it really relies on a majority of the intelligent entities on that cryptocurrency network that are doing the validation. It relies on the majority of them being honest and pro-social and doing the right thing.
Oh, it's like government. If you have 51% voting in a terrible government, you get consequences.
Yes. But what I like about Bitcoin is there's an incredible incentive to be a bad actor, right? I mean, that's hundreds of billions of dollars. All you got to do is figure out a way to co-opt enough computing power and all that money can go and all that power. So it's like a very clear, tempting thing for a bad actor. And yet, at least so far, although it hasn't been a huge number of decades, but so far, it hasn't happened. And that I find reassuring. So if that's true, and the same with government, although the jury's out on democracy as well, as, will it last? But with those checks and balances, it's possible to build similar types of things into a collective intelligence network, because by design, you can imagine systems where each intelligence has a vote or has a vote proportional to its cognitive ability. And as long as the majority of cognitive ability is positive, pro-social, the system works. If you ever get to a situation where the forces of darkness are greater than the forces of good, well, then I think we got a problem.
Very quotable. So one last unfair question. Where do you think we'll be in 10 years?
It's a lot easier to see sort of the trajectory of things that will happen than to do the precise timing. So let me try to answer that question by providing something that might be a little bit useful, which is kind of the sequence. I think the sequence that we're going to see, which I feel much more confident than giving you the precise dates, the sequence is going to be you have AI as you have right now, large language models. The next step on the road is going to be increasing focus on building AI agents, which we're already seeing. A year ago, I was at AI conferences and almost nobody was talking about agents. It was there. It was a research area. But I would go up after and I'd talk to people. I'd say, wow, this is a great idea. Have you thought about using agents? And they're like, maybe, we should think about that. But they weren't doing it. And now this year, everybody's doing it, right? So this is already happening from normal, just large language models to adding agency. That's the next step. Okay. Once you have all those agents, I think a very logical thing to say is how are they going to work together, right? How are they going to work together? So that's going to hopefully lead to more focus on the collective intelligence of agents. I think once people realize that, collective intelligence is kind of not really a sub-discipline of AI. So it's kind of off to the left. But I think if it's brought in, because you have these AI agents, you have to hook them together. I think there's a lot of smart people that will pretty quickly realize we can get higher levels of intelligence by integrating these AI agents in a good way. So then I think you'll get systems that will be built of collective intelligence of agents, and you will get AGI systems that way probably faster than you will get them by training the next large language model with even more billions of dollars of GPUs and everything. And even if you do get better large language models, you could plug them into the network and the network will still be smarter than them. So I don't see any scenario where people just, if they think about it, will not go down that path. So you get these collective intelligence of agents, then you get AGI. It's a question of increasing the cognitive ability and the speed, the clock speed. Now you're going to have superintelligence. You will first have superintelligence in narrow areas, which we kind of already have, like chess. If you take a very limited domain, chess or Go, which has very concrete rules, easy to understand, AI is already far beyond humans. So it is superintelligent in a very narrow area. But once you have AGI, and you should be able to get superintelligent AGI that basically can cover any area that humans can do. And then beyond that, I don't know. I mean, you have folks on one hand like Ray saying there's a singularity, this thing just goes off the charts. You have other people like Paul Rosenblum, who I also very much respect, saying no, it just looks like it's exponential, but it's going to asymptote out. Very few things in science and nature just keep going exponentially forever. Like bacteria, it looks for a while like it's dividing exponentially, and they're going to cover the entire earth with green goo. But they don't. They stop. They run out of food, different things. So there may be some natural limiting factors. It could be data. It could be processing speed. It could be other things that Paul has talked about. So there's some debate about that. But I'm pretty confident that the superintelligence that will emerge will be far greater than you or I. So even if it isn't a singularity, it's going to be big enough that we better have designed the system to be as safe as possible. And we better have done everything we can right now to maximize the chances that it has human-aligned values as it goes forward. So that's what I'm concerned about, this limited time window that we have now. And whether it's what I'm describing or somebody else has another approach, that's fine. But please focus on the design element. Design it to be safe. Don't try to test it in after the fact. That's somebody who sort of missed the quality control course in software development.
And one follow-up there then. What to you would be a leading indicator of AGI? What would have to appear in the news that would make you say, I can now predict that we are this far out from AGI, even if it's only like a matter of days? But what development has to occur that tells you unambiguously that AGI is around the corner?
So I guess we should probably define AGI. That might help.
Well,
and there's many definitions. So let's just pick one. Sam Altman had a decent one, I thought, a while ago. I don't know if he still uses this, which is to say, if you have a system that can sort of perform at average human ability across any task that the average human can do, then we say that it's AGI. It's general intelligence, and it's sort of at human level. And with that definition, you may not stay at AGI very long, right? Because as soon as you hit average human level, just a little bit improvement, and now you're beyond. And so you're sort of technically in superintelligence. So it's a very thin line between AGI and superintelligence. My approach to it is not so much any one milestone. I know people tend to look at that. They're like, well, it beat the world champion in chess, or now it can play any two-player video game, or now it can pass the Turing test under these circumstances or whatever. I tend to look at the system design more. You sort of look at, can it handle any arbitrary problem? Can it handle any arbitrary problem? And it has a way to do it without breaking and saying, oops, flashing a blue screen, I can't do it. It may go slower, it may go faster, but does it have that generality to handle any type of problem that a human could handle? And I think you could almost see that from how is the system designed. Unless you do an LLM, a black box approach, in which you won't have visibility, you'll just keep adding GPUs and keep adding another trillion parameters until finally it seems like it can do anything a human can, and you still won't know how it's representing it. But in the design that I prefer, you will be able to see, here's a design, and we know this design can handle, in theory, any problem. It may be better at some, better than others. And then you could do things like they did with the SOAR architecture. You could basically count the number of solutions and the rate at which it's adding new solutions to specific problems to get a sense of how its intelligence is increasing. So I would be inclined to try to do that, to have a system design that is a little bit more transparent and where you can sort of look inside the black box to see how is the intelligence increasing and when does it get to, there have been studies on humans that 50,000 chunks of information makes you an expert in any field. So does the AI have 50,000 chunks across all these things? Well, then maybe we're kind of getting to that level.
Wow, fascinating. Clearly, we could talk much longer than we have time left, which is about 0. Can you tell our listeners where they can find out more about you and what you're doing?
Sure. So I have a website, a couple websites. The easiest one to remember is SuperIntelligence.com, since everyone knows superintelligence. And on that website, there's a bunch of papers and there's lots of videos. There's links to videos, which I think are very accessible. Some of them talk about the dangers of AI and how to design it. Some of them just are talks, like the one at the AGI conference. So that's probably the place to start. And there's also abstracts of a number of patents. This design that we've been talking about and waving our hands, there's 1,800 pages worth of designs behind it. And you can see the abstracts, the very short abstracts of those 10 patents that are kind of covering this system for people who are a little more technical and interested in that.
Fantastic. Well, Craig Kaplan, I love your vision of the future. I wish you every success in achieving it. And thank you for coming on AI and You.
Peter, thank you for inviting me. This is a terrific podcast. I really hope you keep going. This is fantastic work.
That's the end of the interview. That felt like a quick vacation in the future. I have to say, Craig has an absolutely infectious optimism that I'm sure you could hear throughout our discussion. In today's news, ripped from the headlines about AI, in an article titled Folk Psychological Attributions of Consciousness to Large Language Models, researchers from University College London surveyed 300 US residents to find out whether they attributed phenomenal consciousness to large language models. In this case, ChatGPT. The participants were given a description as follows. As we all know, each of us, as conscious human beings, have an inner life. We are aware of things going on around us and inside our minds. In other words, there is something it is like to be each of us at any given moment, the sum total of what we are sensing, thinking, feeling, etc. We are experiencers. On the other hand, things like thermostats, burglar alarms, and bread machines do not have an inner life. There is not anything it is like to be these objects, despite the fact that they can monitor conditions around them and make appropriate things happen at appropriate times. They are not experiencers. End quote. The participants, 97% of whom had heard of ChatGPT, were then asked to rate the extent to which ChatGPT is capable of having conscious experience on a scale from 1 to 100. The conclusion of the paper was that 2/3 thought that ChatGPT had varying degrees of phenomenal consciousness. The researchers said, quote, the relatively high rates of consciousness attributions in this sample are somewhat surprising, given that experts in neuroscience and consciousness science currently estimate that LLMs are highly unlikely to be conscious. These findings have significant implications for the ethical, legal, and moral status of AI. End quote. Indeed, as we've talked about on the show before, I can foresee the time coming, not that far off, when a court will be asked to decide whether an AI is conscious or sentient or some other attribute. And if that question comes before a jury, well, then this work gives us perhaps some idea of what the decision might be. Next week, my guest will be Rabin Jesuthasan, authority on the future of work and author of the new book, The Skills-Powered Organization, The Journey to the Next Generation Enterprise. That's next week on AI and You. Until then, remember, no matter how much computers learn how to do, it's how we come together as humans that matters.
That's all for this episode of AI and You. Please leave a rating and comment and share with your friends. Get the book Artificial Intelligence and You and see more videos and articles at AIandyou.net. That's AIANDYOU.net, where you can also send us your questions. Thank you for listening.